Good evening, everybody. I'm going to talk today about the topic that I usually talk about in the last couple of years, Eigenlayer. But I'm going to do two things today, which is present the motivation for why we're doing what we're doing. Second, what can you build on Eigenlayer? Some new ideas. Number three, why does chat security work? So that's the three things we'll do today. The subtitle of this talk, if you go to our website, the subtitle says Eigenlayer, the Restaking Collective. Ethereum Restaking Collective. But internally, our goal has always been this, to be the coordination engine for open innovation. I'll explain what and why this means something to us. So if you look at why we have good things in life, there are really two fundamental reasons. There are positive sum games. Right? Positive sum games are win-win games where when many of us come together to do something, we all gain something. And there are two prototypical positive sum games. I think pretty much all of the games I know are one of these two types. The number one is innovation. Innovation is when I take a non-resource and use an idea and convert it into something that is useful and productive. Like you take oil and you can make energy out of it. You take air and you make spectrum out of it. You take sand and you make silicon out of it. So innovation, leads to something which is, a net gain. The other kind of a non-zero sum game is coordination. We all come together to do something which is greater than the sum of the parts. And these are the two positive sum games that we know exist. And if you look at functioning societies, they're basically composed of these two games in interesting manners. And here is an example. You can think of how these two layers interact with each other. A layer of open innovation and a layer of coordination which lies underneath it. For example, if you take a country like the United States, to the extent that it is functional, basically because there is an underlying coordination layer of government, which is a democratic government, on top of which there is a free and open market where people can interact with each other and create positive sum games. So what we aspire to be is mimic this structure for digital platforms. To be the coordination layer for open innovation. And when you think about digital platforms, you want to build all kinds of interesting applications with credible commitments. You go and build something on top of a Twitter API, and you don't know when the API is going to be shut down. Right? What you want to do is you want to build digital platforms which are very rigid. When you build something on top of something else, you know exactly what you're building on top of, and there is a certain rigidity to these platforms. This leads to a certain amount of open, composable innovation on top of it. But to do this, you need a coordination layer which is highly flexible, which is highly programmable. And that's what we aspire to do with Eigenlayer, leveraging Ethereum Trust. Okay, so what is Eigenlayer? I'll just give a 1-minute intro for those of you who may not know. And if you know, you'll just get bored for a minute, and then I'll switch into talking about something interesting. So what is Eigenlayer? Some of you may have heard the word restaking, which became a popular meme out of our project. But really, it's actually, if you look at the core of it, what we're building is permissionless programmable staking. What is this? In Ethereum, what is the root of trust? Why is Ethereum as a blockchain trustworthy? Is because underneath Ethereum is a layer of trust coming from staking. Nodes put up a bunch of stake and make a promise that they're going to follow the Ethereum protocol faithfully. And if they don't, they are liable to lose their Ethereum. That's why there is a root of trust underneath any proof of stake blockchain like Ethereum. What Eigenlayer lets you do is to take the same ETH and make additional commitments on top of that Ethereum. You're not only running the Ethereum protocol correctly, you're going to be promising that you're running all these other protocols that you opt in voluntarily into. You're running all of these things correctly. So that's called restaking because you're taking the same stake and making additional promises, but really it is permissionless, programmable staking. It's programmable staking because now you can opt into general conditions which are programmable, and it's permissionlessly programmable. Like anybody can write these new conditions. You can have people build new oracles, data availability, build all kinds of interesting things, which I'll talk about next. But these services, we either call them services or middlewares, or sometimes more precisely actively validated services. These services require some kind of an active validation. These nodes have to go and do some active work in order to secure these networks. So what does a middleware or an AVS, an actively validated service, comprise of? It comprises of two parts. One is an arbitrary off-chain code. You can take and write your code for your data availability or Oracle or whatever, an arbitrary code, and package it into a container. And you can ship this to the Eigenlayer network. And the other thing you can do is you write a smart contract on Ethereum. Eigenlayer itself is not a new chain or a layer 1 or anything like that. It's just a series of smart contracts on Ethereum. On Eigenlayer, the Eigenlayer contracts talk to the middleware or the AVS contracts, and in your AVS contracts, you just specify some of the coordination conditions. What are the coordination conditions? For example, who can register into my service? Who can, and if they register, what is the payment conditions that they're opting into? And number 3, what is the slashing conditions so that they are liable to hold to their promise? So that's what Eigenlayer is. Eigenlayer basically allows anybody to come up with new middlewares or services and then ship it to this network. And this network takes care of the decentralized trust underneath it and then enables that to be supplied flexibly. So one way to think about this is reminiscent very much like the cloud, right? So what is going on in the cloud is, you write a new service and you don't have to actually go and run this service yourself. You can build a SaaS product, a software as a service product, and usually what you do is write your code, put it up on Amazon or AWS, you pay the Amazon fees, but every time somebody uses your service, they pay you a drip of a fee. And if you look at the cloud era or the internet era today, you see there are thousands of thriving SaaS services, right? Hundreds of unicorns built on software as a service. One of the reasons is when you're building a software as a service product, you're actually taking something highly specialized. Like, let's say, how do you do authorization for social login, right? Like OAuth. And you just build that one layer, and everybody building applications can now use that one layer. A typical application on the internet uses 15 SaaS services in the backend. So what we aspire to be is something similar for the crypto era. So you write your new decentralized service. So the first thing is you cannot write a similar SaaS service for the crypto world if that service has to be trustworthy, because that is the root of trust of that service coming from. What Eigenlayer does is provide a shared security system, a common staking pool, a common set of operators, which can then opt into these various services and provide security. So what kind of services are we talking about here? I'm going to provide a classification of some of the really interesting categories of services that we've been seeing. So the one category that is very obvious in the Ethereum roadmap is rollups, right? Modular blockchains. So what kinds of services are needed in order to actually build rollups? One of the most important services needed is a data availability service, because you have a place to publish data. And EigenDA is a hyperscale data availability service built to be an adjacent layer to Ethereum. But there are lots of other services needed in order to make the rollup era work. For example, you need a mechanism for rollups to sequence the transactions, order the transactions in a decentralized manner. Today, you have centralized sequencing services. People are building interesting decentralized sequencing services on Eigenlayer. One of the things about sequencing is many people may have different applications, may have different models of sequencing. Somebody may want to do a maximal MEV auction. Another application may want to do a first come, first served ordering. Another application may want to use a threshold encrypted mempool. All kinds of interesting applications. Different kinds of sequencing protocols can be built on Eigenlayer. Bridges, one of the problems with rollups, rollups of course have native bridges, but these bridges take a large settlement latency. So it takes a lot of time to settle. In the case of an optimistic rollup, 7 days. In the case of a ZK rollup, you may still wait for several hours in order to batch enough transactions to get the ZK scaling gains. So, but you may want to do fast bridging across these rollups, and one way to do it is if you have enough economic security. There is a AVS committee which basically underwrites that, hey, this transaction actually is confirmed on rollup one, and then you use that confirmation to then move value across these rollups. You get a certain amount of economic security in your bridge. So that's another category we're seeing. MEV services, which is, I mentioned auctions, threshold encryption, all these kinds of things. Another example is watchtowers, right? Imagine you're running an optimistic rollup. Today there are a handful of major optimistic rollups, and when you have a handful of them, these are so important that there's a large ecosystem of RPC providers, exchanges, and other things, which are anyway watching these rollups and will be able to alert everybody if there is a fraud or a fault in these systems. But as we go beyond like these major optimistic rollups to thousands of application-specific rollups, each of these rollups may have nobody watching these rollups carefully, and so they may be subject to the tragedy of commons, and eventually have faults that never get settled. So watchtowers is another kind of a new category that we're seeing built on Eigenlayer. But the idea is that you want to have a credibly neutral group of nodes, maybe a handful of nodes which are watching your particular service, but these nodes get rotated and sampled from a large pool of operators. So these are examples of roll-up adjacent services that we're seeing on Eigenlayer. What other services are we seeing? A very interesting category is what you can call as a co-processor, or maybe another word is a serverless lambda. Right? Like if you go on AWS, this is one of the things you can get, is what if I want to run a stateless service? Rollups are nominally thought of as highly stateful. They have memory and then they retain it over time. But you can actually have co-processors which are stateless services. And there is a very interesting category that is being built on Eigenlayer. What are these services? One of the examples is what I call the category of intelligent DeFi. So what's going on in this? So suppose you want to run like a DeFi protocol. Let's say you want to run a Uniswap pool, but in this pool, I want people to deposit money not based on a static price, allocated according to, let's say, X, Y equals K, but something very dynamic where an AI algorithm actually runs and analyzes all the previous data and then recommends what price you need to set in order to maximize the efficiency. But to do this, you need a service that is actually highly trustworthy, which brings in this information. Because imagine if somebody comes and sets like 1 ETH is equal to $20 and your entire pool gets raided because of this wrong price feed. You need this to be highly trusted. One of the ways you can do it is to run an AI inference as a co-processor on Eigenlayer. You have nodes that stake enough economic capital and make a promise that I'm running the service correctly and then input it into the Uniswap V4 hook, for example, and then you actually trust it heavily because in case that service goes wrong, you can actually slash a large amount of ETH. In fact, you can make the system very tightly crypto-economic by making sure that the total amount of transactions that you do is less than the amount of value staked. So there's no way that an attacker can profit by attacking your service. So AI inference is one example. But you can also think of, you're sitting in Ethereum, but I want to get a commitment that if you run this Linux program on top of this inputs, this is the output. It's a stateless execution that you want. And you can actually run those kinds of things. You may want to run a SQL database. You're sitting on Ethereum, I want to access a SQL query, but highly trusted. Do this on Eigenlayer. You can have decentralized ZK provers. All kinds of interesting things that you can start building on top of this common chat security system. You can go beyond this and start building other cryptographic services which are not available today and are difficult to build in the absence of something like Eigenlayer. I'll talk about this Eigencert later if I have time. But TE networks. So trusted execution environments are hardware enclaves where Intel and AMD and others actually make these enclaves which are much more rigid than a regular computer, and you can know that that particular program is running inside this computer. You can actually build networks of trusted execution environments by actually having staked nodes run these TEs. We already have several protocols, for example, Puffer, which is building TE-based staking, so you can reuse this TE for other kinds of applications. You can build secret sharing. Imagine I have a secret and there is a condition under which this secret can be released, but till then the secret needs to remain a secret. One way to do it is to take the secret, encode it into smaller chunks of information and distribute it across the network. And the network only releases this information if certain trigger conditions are activated. You can do more complex secure multi-party computations where you can take, you can create things like private DeFi where like this common state doesn't exist anywhere but remains dispersed through the network. You can build fully homomorphic encryption with threshold keys where the threshold keys are encrypted and distributed across the Eigenlayer network. There's another category we're seeing, which is the category of proofs. So this is something that I found fascinating because we did not envision any of these things when we started. For example, one of the cool ideas is a proof of location service. What's a proof of location service? Imagine there's a node and you want to assert that a node operator or a user belongs to a certain geographical location. How do you get this information into the chain? One way to do it is if you had a decentralized group of nodes which can use network latencies. These nodes send pings through the internet network and then ascertain whether you're within a certain radius by looking at the latency with which you respond to them. And you can ascertain proof of location through a decentralized network. You can build proof of machinehood. For example, this idea that there is a protocol called Automator which is building this. The idea that you have an attestation that this is a unique new device, a unique Apple device, which is basically accessing this system. You can build proofs of identity. Imagine you have a HTTPS server and you have only symmetric cryptography, but you want to make provable certificates of this. You can actually create certificates of that you're actually accessing this correct server. We have Reclaim protocol and others building this. So you can build very interesting sets of applications on top of Eigenlayer. And finally, a category which I think we anticipated would be very interesting, and we're seeing some really new ideas there, is the fact that almost all of these other services are either relying on economic security from Eigenlayer, or they're relying on decentralization, the fact that these nodes will not collude with each other in order to build these services. But there are also certain services which specifically take advantage of the fact that it's the Ethereum stakers that are restaking. The fact that these Ethereum stakers have a role in production of blocks in Ethereum itself. I'll give you just one example. This is by Justin Drake from the Ethereum Foundation, called based pre-confirmation. Base sequencing is this idea that I can sequence transactions for my rollup, not using a separate sequencer, but using the base layer, Ethereum itself, to do ordering of transactions. But one of the problems when you give up a single central sequencer is you lose this like really amazing experience you get on Arbitrum or Optimism today, which is instant confirmation, right? When you send the transaction to the base layer takes so many seconds to make another block. It's too slow, and you may not get the same kind of pre-confirmation. One way to enforce pre-confirmation on base sequencing is if these block proposals are staked on Eigenlayer, they can immediately issue you a receipt saying that I am going to include your transaction in the next block, or whenever whenever I am the proposer for the block, and that gives you an instant confirmation that your transaction will be included. And if this guy doesn't include it, he'll get slashed on Eigenlayer. So many interesting applications that can be built on top of this. And one thing you'll notice here is I'm not talking about end user or customer facing applications here to be built on top of Eigenlayer. These are really like SaaS kind of services. And when you think of an application will use many of these primitives to then run itself. I mentioned intelligent DeFi as an example of a category which may use AI inference, it may use secure multi-party computation, we use some kind of proof of identity to ensure legal compliance, all of these things. So any given application will mix and match these different services. And the view that we have on the modular era is very different from what some others may have. That there are a few modules, like there's consensus, there is data availability, and there's execution. That's not our view. Our view is there are going to be thousands of modules built with very different properties, and each one hyper specialized in certain types of actions. And that's exactly what we see in the cloud era, and we expect something similar to happen with Eigenlayer. Okay, so one of the things that if you see the previous picture, and some people look at this and they get scared. Hey, one layer, and all these systems building on top, is this rigid? Can this be secure? And so the normal mental model people have about restaking is they think of this like, oh, it's some kind of leverage, it's some DeFi degen stuff, and I want to correct the perception here. So Eigenlayer is built on the principle of shared security. I'll explain what it is and explain why it is a really powerful force. So number one, shared security is strictly better. What do I mean by this? Let's not think about this as staking just between Ethereum and like lots of services. Even inside Eigenlayer, when you stake, you're staking to many services simultaneously. So the same principle applies even when you're staking across Ethereum and Eigenlayer. But here is a simple way to think about it. Suppose you have one world in which $1 billion is restaked into 1,000 services. All the stakers are restaking into every service and running it. Okay? So this is one world. Another world in which $1 million is staked exclusively for each service. Which world is better? Okay. In the first world, to attack any one service, I need to acquire $1 billion worth of capital. Not only that, if I attack that service, I'm liable to get slashed and lose potentially all of my $1 billion. So in the first world, the cost of corruption is actually much higher. To attack any one service, you actually have to attack this entire pool. And one of the things that happens in security is the larger the scale of money, the more impossible it becomes to run away with attacks without leaving physical traces. Right? There will not be enough liquidity in your pools to drain. Like there will not be enough anonymity for an attacker to escape. So shared security hardens the security surface by aggregating security. This we see everywhere in the real world. Cities don't have armies, nations have armies. It's because of the power of shared security. Exactly the same thing happening here. Okay, one way in which shared security is worse. One way in which shared security is worse is you don't have any attributability. You have this pool of 1 billion and everybody's sharing this 1 billion. Whereas in the other world, I had my own 1 million, and as long as I'm, my equations work and I don't have too much economic loading, I can actually make the system secure. So in that way, actually, maybe there is an advantage in the second world. And not to be left behind, Eigenlayer has a new mechanism to deal with this for providing attributable security. What do I mean by this? We have one of the things that happens on Eigenlayer is that when your service, when you make a provable fault on a particular service, that service can trigger slashing. One of the things that can happen is many the stakers can create violations on many protocols simultaneously. This is the typical attack in a pooled security system. And what we can do to minimize this is to create a certain attributable security. So what happens is, instead of in our V1 of Eigenlayer, what we do is, if slashing happens, we just burn the ETH. This is exactly what happens in Ethereum today. But what we want to do is to go a little bit forward from here. And what each service can do is to buy insurance for a subset of stake. Imagine, as I explained earlier, there's $1 billion stake. And if there's $1 billion stake, there's potentially $1 billion slashable, or $500 million, depending on what the quorum size is. Let's say there's $500 million slashable, and when slashing happens, the slashed amount is redistributed to the different services. So what the protocol does, a priori, even before the bad event happens, is allocate this $500 million of slashable amount to various ABSs. Each of the ABSs bid for the slashing right. Okay, so they acquire an exclusive right to redistribute. Instead of burning the money, you redistribute the money to the different ABSs, to the different middlewares, to different services, and each service can buy insurance of a certain portion of the stake. So imagine in this previous example, I was talking about this intelligent DeFi, right? AI service is bringing in these price feeds to adapt a Uniswap pool. Let's say this Uniswap pool has a trading limit of less than 100 million per day or whatever the fraud-proof period is. And so that service, if it buys an insurance of 100 million, then this service, the application can operate in an unconditionally safe manner. Because if at all something wrong happened on Eigenlayer, you will be able to slash them, extract the, and if it buys more than 100 million of insurance, it can actually guarantee that to its users that anything wrong goes on Eigenlayer, you will be able to slash the guy, get the money, and redistribute it back to those guys. Building one of the tightest cryptoeconomic systems that exists. There's nothing like this today. Okay. The powers of shared security go beyond this. There is an economy of scale in shared security. What is this economy of scale? Imagine an application like the DeFi protocol that I was just mentioning uses many different services, not one service, but many services. It uses an AI inference, it uses a bridging service, it uses a privacy protocol, all of them in order to provide an end user application. And this end user application transacts $100 million of value. If each of these services were run on independent staked pools, and you wanted insurance, you have to buy insurance separately for the same amount, 100 million, on the Oracle protocol, on the AI protocol, on the data protocol, whatever set of protocols you're using. Instead, when you have shared security, when you have the same pool of stake that's restaked across all these services and run across all these services, then you only need to buy insurance 1x instead of 5x. Shared security reduces strictly the cost of security. And finally, shared security leads to elastic scaling of security. What do I mean by that? Like, Amazon cloud is called EC2, elastic compute. Why is it called elastic compute? Is because you can go and buy as much compute as you need, and there is a statistical multiplexing, which is each of us want different amounts of compute at different times, and we can average this by having a single large compute infrastructure. That's exactly what Eigenlayer allows for security. So Eigenlayer is elastic scaling of security. What does this mean? There are many applications, each of which need independently varying amounts of security. Imagine there is a bridge protocol and there is an Oracle protocol and so on, and each of them has varying demands over time and they will need varying amounts of security. And so they can go and draw from a common pool much better than if they had their own pools. Because if I have a variance of, I may need, as a bridge, anywhere between 10 million and 200 million, if I were to have my own staking pool, I have to provision for the worst case of 200 million. If there was averaging across many, many services, then maybe there's just like a few $1 billion of common pool and all of us can buy security based on what we need. There is a statistical multiplexing effect. Awesome. So with that, I can conclude this talk. I think I covered most of the important things. I want to stop this talk just making the following observation. Our goal we started with, which is to be the coordination layer for open innovation. And to be the coordination layer for open innovation, what we're doing is providing shared security, a system where there is a common pool of stake, a common pool of node operators, a common pool of decentralization, and a mechanism by which this can be shared across many, many different applications or services, all of which then can be used by end user applications in different ways of mixing and matching. Thank you so much for this opportunity to do this.